Welcome back, protein coders. Let's build some coding muscles. Today we're gonna see detection of cycle using disjoint set union data structure. For undirected graphs, we already have seen two methods, right? Using DFS and using BFS. Today we're gonna see how we detect cycle in an undirected graph using DSU. Let's see. We have a graph, okay, having nodes 0, 1, 2, and we have a parent vector, adjacency list. Now we want to perform union operations on the edges, okay? But before that, suppose, because it's an undirected graph, right? So suppose we have an edge from 0 to 1, then there will also be an edge from 1 to 0, right? And we don't want to do the duplicate operations. So that's why we will always consider u less than v, okay? Because there will be an edge, right? If we have an edge from 1 to 0, let's say, then we also have an edge from 0 to 1 because it's an undirected graph. So this is one point we will keep in mind, and we will do union. Now let's do the union. So we have an edge from 0 to 1. So let's do the union and bring 0 and 1 in the same set. And we'll mark the parent of 1 as 0 in the parent vector. Now we have another edge from 0 to 2. So again, because 0 has a smaller rank, so we'll connect 2 to the 0 node and mark parent of 2 as 0. Now see, we have a node from 1 to 0. We will not consider this. Else we will consider 1 to 2. And what we found is, while doing union, we first find the root parent, right? So if we find the root parent of both of the nodes, it comes out to be 0. They are already present in the set. What that means is we got an extra edge. We got an edge connection, right, in the same set. What this implies is these two nodes are already connected, and now we are connecting them with an extra edge. This means cycle is present. Congratulations. So that simple it is. Now let's see in the code how we're gonna implement this. So we have our function and we also have our class DSU, which we discussed in our previous video. Now let's initialize the DS object of our class. What we're going to do is we're going to traverse u from 0 to v and auto v in the adjacency list of u. Okay, we will get the edge pairs u and v from here. Now for every u and v pair, we will check u should be less than v to avoid duplicate operations, right? Now we will find out the ultimate parents of u and ultimate parent of v. And if pu equals to pv, that means before doing the union operation, we have found an edge, okay, in the same set. So we will return true. At the end, we will do the union operation. And we have to write ds.find, okay, ds.union pu comma pv. At the end, if we didn't find any cycle, then we will return false. And that's it, guys. This much is the code for this. That's how simple it is. Let's revise few key points. While performing the union operation, we always check this condition u less than v to avoid duplicate union operations. Okay, and before doing the union, we will check the ultimate parents. If they are same, that means we have got the edge in the same set. That means there is a cycle present. Now we saw the code for it, right? We are checking the same thing. If pu equals to pv, that means we got a cycle, we will return true, or we will do the union operation. And at the end, if we don't find any cycle, then we'll return false. So that's all from my side, guys. If you have any questions, please mention them into the comment box. You will find the problem and the solution link into the description box. If you don't understand, don't like, don't subscribe. But if you do, please show some support. Keep practicing, keep smiling. Thank you.